being recorded. It's a don't talk. You understand? Now that you're going to be able to sit there? Okay. Tangent properties. This is the first section of our circles. We already went over all the terms. Your quiz is going to be over all of the stuff we just talked about. And these two properties are going to go over. Okay? Okay, quick review. This is all from that circle map that we just did. How to write this down. Okay? That's what you really want to do. Congruent circles right here. Circles that have what? Same radius. Good job. So circle, congruent circles, B. Not second circle? B, no, that was C, no. A, two circles that share the same center. That was way back from chapter 1. Okay? Radius, you know how to name that. It's the same thing. The chord is the same thing. The diameter is what kind? The longest chord. Okay? Remember that for tomorrow's quiz. That's the longest chord. Tangent, what we're going to focus on today, but what does that do, writer? What does the tangent do? We just talked about it yesterday. What does the tangent do, writer? Corners? What? Thank you. Now we have to circle one point. And what is it? You say it. What is it? A line, right? Central angle, an angle that is at the center. Its vertex is at the center. So look at that. This would be angle G. Nope. How come I can't use one letter? Because there's two different angles there. You can't just use one. So angle D, G, E. That's a central angle. The other one is angle A, G. Oh my God, who's still talking? What did I just say? Angle A, G, E. Okay? Those are two central angles. The other thing you're supposed to remember is that angle right there is the same degrees as what? Who remembers back way back from chapter 1? The degree on the not the circle, what's that called? The part of the circle, what is that called? It's intercepted arc right here. So if this was 20 degrees, then arc DE is how much? 20 degrees. You learned that way back in chapter 1. So you got to kind of bring that back. Okay? I know it's been a while. Okay? Which, that right there is a minor arc. Make sure to use the correct symbols for that. Major arcs, no. 3 letters. This has to be associated to a diameter. You can't just make it up. Like, for instance, you can't say BAE. Even though that one looks like a major arc. But I'm saying if B was like right here, okay, or let's say it was Z. You can't say ZAE just because it looks like the semicircle. It has to be involved with a chord. Diameter. Okay? Tangent circles, that one's narrowed from that. There's a picture of it right there. C. Okay? It's two circles that what? That share one point. Just like a tangent line touches a circle. Questions?
So semicircle, it's only 2 letters, right?
No, 3.
What B? So you want to say B-O-A on it. B-O-A.
Yes. But you can't say B-A. If you say B-A, you don't get some points. Because it has to have 3 letters. Okay? So you're going to have like something like this on tomorrow's quiz. I'm going to give you some pictures over there. You're going to have to name them. Okay? Just like that assignment you just created. Okay? All right, let's talk about the actual tangents. Okay? Investigation 1. First things first, construct a circle. So get your compass. Make sure you draw your center point. Steven, can you not talking? Why are you not talking? Okay, well, if you read the board, it says that you need a compass and a protractor and a calculator. Make sure I say on your class, so I can talk about what it means to not talk. Keep on talking. go up. That's one right now. Okay, so draw your circle. Make sure you do collateral. You have to do collateral. Go put that back. Oh, that's like we have since the beginning of the school year. Backpack. Then it says label the center U. And it says using your straight edge, draw a line that appears to touch the circle at only one point, and then call that T. So get your ruler. And use the straight edge off of the protractor. Use your straight edge off the protractor. And so now it's kind of hard sometimes to just get it to touch at exactly one point, okay? So just do the best you can. So there it is. And label that point T. What is point T called again? Point of tendency. Do your best to find it. After you do that, it says use your straight edge and construct the radius UT. So get your ruler and connect T to U. Once you've done that, the last step, it says use a protractor to measure the angles at T. What do you conclude? Did you got them all perfect right at 90? Yeah? Alright, so then now we've got a good estimator when you make it exactly 1 point, okay? And that's what it should always be. That's what it should always be. That's 90, of course that's 90 according to the linear pair. Okay? So first conjecture you have to memorize. A tangent to a circle is length to the radius drawn to the point of tendency. What word is that? What? Perpendicular. What's the symbol? Upside down T. So we don't want to write out the long word perpendicular. Just draw an upside down T. Alright? Gotta remember from here on out. If you draw other segments, what kind of shapes could you get involved with this picture? What kind? Right triangle. So you know what that means? Pythagorean theorem or trigonometry. So see how that doesn't go away? Okay. What else? What else has right angles? Squares, rectangles, so remember those properties. Okay, that's one of the two. There's just one more. Okay, draw your circle again. Make sure you draw your center point. Okay, label that center E. And it says pick a point outside of the circle. Here, and label that one in. Then it says draw 2 lines that go through that point, but are tangent to the circle, using your straight edge. So just use the edge of your protractor. So get your ruler or your protractor, use the straight edge, and connect it. So there's one. So you need to find, then you need to do one more. Move up. It could be anywhere, but it has to fall at a certain spot. It has to be tangent to the circle, and it has to go Okay, then it says, mark the points of tangency, or mark where they appear to be tangent. Label those A and G. Okay, it says compare the tangent segments. So earlier we said, well, tangents are always lines. Well, what's part of a line? Points and segments. There's a bunch of different segments on a never-ending line. So here on these two tangent lines, there's actually two tangent segments. So know what we're talking about when we say tangent segments. Everybody know what that means? Here's the tangent segment, AN. That's a tangent segment. Where's the other tangent segment? GN. Okay, so it says compare those two. What do you think, guys? They're exactly the same length. If you were to measure in centimeters, it'd be very close. So you would use your compass, it'd be very close. The only reason why you'd be a little off is if you're off on your point of tangency, and we're just drawing it, you know, just eyeballing it, I guess, so to speak. So sometimes we're a little off. But they will be very, very, very close. Who's right spot on? Who's came out exactly correct? But my point of tangency was good. Okay, so this is the second property you have to have memorized. Okay? Tangent segments to a circle from a point outside the circle are congruent. You can write the word or write the symbol. Okay, so two properties you have to have memorized. Okay? Just so you know, this will be your hardest test for this 9 weeks. Okay? Yes, for this 9 weeks, this will be your hardest test. Why? Because circles have a lot of different properties that you have to memorize. These are the first two out of maybe another 11 or 15. Okay? So make sure you're on it this 9 week or this live test. Okay? You got a little, I don't know, little help with that similarity project because a lot of y'all will probably get A's. Y'all are still being graded. Third period's been graded, the majority of them got A's. Okay? So make sure you're on it on remembering these conjectures/theorems. Okay, 3 examples that we'll do and then we'll be done. Okay, copy the first one. The first one, it has a circle. You don't have to use a compass, just sketch it real quick. Okay, sketch it real quick. You can go to the next page. If you have room at the bottom, then you can squeeze them in on the bottom. Or just write examples. Make sure you write examples. So you have a circle, you've got a couple of segments, and then you've got that angle out there, and we got to figure out the measure of that angle. So look at it for a little bit, and then see if you think you know how to do it. Raise your hand. You're telling me what what do you got? How'd you get that? Not 160. 360. Very good. This was the main property that you should have used just from a second ago, right? Because both of those are 90. And then y'all probably couldn't hear Lane mumbling, okay? But here's what he said. He said these two right here subtract from 360 because the quadrilateral always adds up to 360, and then those two will add up to 180 because 180 and 180 equals 360, so therefore this is 50, and that's correct. So here's a quick way you can always remember. These two right here, those are always going to be 90, right? So these two are always going to be how much? 180. Okay? So from now on, just take that, right to that. By the way, what is the measure of this arc again? 130. Remember, it's the same as its central angle. Okay, let's go to the next one. Angle X. What's the measure of angle X? Right. 70? How do you get that? Okay, and why are they the same? Because why? I'm talking to writer. Why? How come those are the same? Okay, well, they look the same. That's not it. Because a lot of times that makes a lot of things look alike and they're not the same. Lisa, why are those the same? Why are these two angles the same? Nope. And why are those two angles the same? That's it right there, because it's an isosceles triangle. This property regular is what we just did, it was the second one. Okay, therefore that makes it an isosceles triangle. And what do we call these two angles from way back when? Those two called base angles. The base angles are always congruent. Okay, so 70 degrees. All right, last one. What is the measure of segment SA? What is the measure of segment SA? Raise your hand, you'll just blurt it out. Anybody? Sure? Okay, Connor, what you got? How do you try to get 7.5? What, tell me what is exactly congruent? OATA. Okay. Make that big up. I can't hear you, you're talking. 10? So I'm assuming you're just subtracting part of energy.
Well, it's because both of them are making this LS and TO. So that must mean
That's right. So you're saying what Connor was saying, that's kind of not saying that TA is the same thing as OA? Why is TA congruent to OA? Raise your hand if you can tell me that. Why is TA congruent to OA? Raise your hand if you can tell me. Who said they can't be? Why can't they be? Because it's the hypotenuse. By the way, anytime you see a picture like that, you're not, make sure you always go with those right angles in there. That's the first thing that you have to talk about. Okay? They can be the same because OA is called a hypotenuse, which is always the largest side. I'll give any one of y'all $1 million if you can draw me a right triangle in which the hypotenuse is smaller or even equal to one of the legs. Okay? Yeah. $1 million. Okay? The reason why I'm saying $1 million because you can't.
I'm looking it up right now. Einstein probably did it.
Anyway, okay. So they're not the same. So how do we figure it out? I right there. So what is this whole thing? 87 what? 81 what? All right, and then you subtract what? So what does that say?